And welcome again. Let's solve a different version of the same problem we discussed in the earlier video. And the statement of the problem is: water is poured from above through a hole in a hemispherical bell. There's some kind of bell here, hemispherical bell, lying tightly on a rubber mat on a table. You can see the figure. When the water level reaches the hole, it is here, water begins to flow out from under the bell. Find the mass of the bell if its internal radius is r and the density of water is rho. It's the same problem but in a different manner. Its presentation is different, but it's the same problem. How? You can see here, if you can imagine that the bell together with the water poured inside it is just standing on a weighing machine, then the skill readings are obviously determine the force of gravity acting on the bell and water. On the other hand, sorry, at the moment when the bell begins to rise, it stops pressing on the support and consequently on the weighing machine, and only the water presses on the support this time, and the force of water pressure is greater than the force of gravity acting on it. Since the bell narrows towards the water, so at the moment of consideration, that is when water starts spilling out from here, and you can say that the force of water pressure is equal to the sum of forces of gravity of the bell, forces of gravity on the bell and the water in it. And you can see here that the area of the base of the bell is equal to pi r square, and the water is poured into it to a height h equals r. Therefore, the force of liquid pressure, you can write here as pressure force of liquid pressure simply as rho gr. It is a pressure at the bottom multiplied by pi r square, and that is simply pi rho gr cube. And we know that the volume of the hemisphere is half of 4 by 3 pi r cube, that is 2 by 3 pi r cube. Therefore, the force of gravity on the water is simply 2 by 3 pi r cube rho multiplied by g. And let's denote the mass of the bell by m, and we keep the forces balanced. That means we would like to write the equation of force balance, equilibrium condition, force dynamics equation. And you can see here that this force pi rho g r cube will be equal to 2 by 3 pi rho g r cube plus mg, and you can find the value of m from here, and this will be definitely equal to 1 by 3 pi rho r cube. And the described method makes it possible to solve similar problems in cases where the bell has a more complex, even bizarre shape. And in order to find the mass of the bell, it is enough to know the volume of the inner part of the bell, which is filled with water or some liquid, and the area of the base, and the height to which water must be poured so that it begins to flow out from under the bell. And you can solve any problem like this. Thank you very much for watching.